Hello, everyone. Welcome to our session. My name is Richard Wright. I'm one of the Manhattan Prep instructors based in Brooklyn, in New York City. I want to thank GMAT Club for putting this together. This should be a great session today. We have a live chat that I can see, so go ahead and say hi in the chat if you feel like it. Also, this will be an interactive session. I can't see or talk to you, but I will be interacting with everybody through the chat, asking the audience questions and things like that. So the topic today is how to master quant with the UPS framework, which is understand, plan, solve, and fast math. So we're not going to be talking today so much about math topics, right? I'm not going to teach you anything about algebra or quadratic equations or geometry. But the stuff we're going to be talking about is a very important component of getting good at the math problems on the GMAT generally. So that's what we're going to be covering. Before we jump in, I did want to say that GMAT Club is doing some great stuff to help support people in Ukraine right now. You can donate. If you look at the chat, there are some links showing up. They're running some special sessions to support people going through what's going on in Ukraine right now. So definitely please do that if you can. All right, so let's jump into the presentation. So we're going to talk a lot about estimating today. No matter how good you are at math, there are definitely going to be problems where the right move on the GMAT is to estimate. Because if you're fast at doing mental math in your head, great. But if you're estimating, you're doing fewer steps. And so even if you're very fast at the mental math, you will still get done faster if you estimate. So we're going to talk about how to look for cues on when you should think about estimating, and also how to do it effectively, because there are a few different ways you might approach it, and some are better suited to the GMAT than others. We're also going to be talking about a process we call benchmarking. So benchmarking is basically a way to, again, do a lot less math and still get to the right answer without doing the full, many step algebra that you could do to get to the end of a problem. It's sort of a shortcut. And then throughout the presentation, we'll be talking about the understand, plan, solve framework. If you do decide to go ahead either with the Manhattan Prep course or if you purchase our textbooks or other materials, you notice that this is something we weave throughout the quant lessons. And I'll talk about what we mean by understand, plan, solve, and why it's valuable. And then I'll give you some examples of how it applies to particular problems. So let's go ahead and jump in. Also, if you ever have a question, feel free to just pop it in the chat. I will be monitoring it. And I might not answer it immediately if I'm in the middle of talking about something, but I will do my best to get to every question that people put up. Okay, so estimating is a key strategy on the quant section of the GMAT. And the basic idea is, look, you don't necessarily need to get the exact answer to every problem. All you need to get is a selection between the 5 answer choices that they give you, A, B, C, D, and E, right? And sometimes you can make a very confident, correct selection of the answer choice without actually doing all the math and getting to the exact answer of the problem. So let's give you some examples. Let's give a real world analogy first. Let's say you're rushing into a meeting. You have 30 seconds, and it's an important meeting. It's not something you want to be late to. And someone pops up in front of you and says, hey, I have an investment opportunity for you. You give me $10,000 today, and I'll give you 5% of the money you put in every month for the next 2 years. And the question is, do you want to hear more? Is it worth being late to your important meeting to hear more from this person about this investment opportunity, right? Now, you could do all the math, and for certain people, this problem would be simple enough that you could just bang it out in your head in a couple of seconds and make a smart decision. But for a lot of people, that's more math than you could comfortably and confidently do in 30 seconds. 5% of $10,000 every single month for 24 months. So how could you estimate to get a quick answer to this problem and make a decision about whether it's worth showing up late to your meeting and listening more to this person? So one way is you get a quick piece of the math that's going to be important. So 5% for each month for 24 months. Well, hey, in 10 months, 5% is 50%. 50% is easy math to do. That's half the money, right? So in 20 months, if you get 50% in 10 months, in 20 months, you'd get 100% of your money, which means that after 24 months, you don't know exactly how much you would get. You don't have to know exactly how much you would get. You know that it's more than the amount of money you put in. So it would be a profitable investment opportunity. Right? Now, that may or may not mean it's a great investment opportunity, but it's definitely a profitable investment. So now you might be interested in hearing more, right? And we haven't bothered to calculate exactly how much money you're going to make. All you figured out is, if it's more than 20 months, I'm going to make my money back. So at least I would make money. And oftentimes on the GMAT, that level of understanding is all you really need. That's the level you would need to select an answer choice. And we'll show you some examples with real GMAT problems in a moment. So real world business is not, with a very small number of exceptions of very particular careers, is not really a math test, right? The ability to do tons of calculations in your head really quickly, it's not really that relevant. There used to be some jobs on Wall Street, like floor traders, where that was relevant. But with the advent of computers, even that stuff is almost irrelevant for almost everyone in the world today. So the GMAT's not testing you on that. It's irrelevant for business. It's irrelevant on the GMAT. What the GMAT is testing you on is how you can intelligently make smart decisions to get to the right answer in a hard problem quickly. And estimating is a crucial part of that process. So let's take a look at some potential answer choices. We're not even going to look at questions. We're just going to look at answer choices right now. And we're going to talk about how you can think about estimating in cases like this. Now, this first example, the answer choices are all really far from each other. So this is a great opportunity to estimate, right? A and B, that's a 10 times difference. B and C, that's a 5x difference. C and D, that's a 2.5 times difference. D and E, that's almost a 3 times difference, 2.5. So again, these are all far enough away that this is a really good opportunity to estimate generally. And your math would not need to be that precise to get to the right answer here. Even some answer choices that look closer together and like they might not be as good an opportunity to estimate can still be a great opportunity to estimate. So if you look at this second example here, well, these are all percents, like they're between 10 and 25. That's not that big of a spread. You know, it's not like going from 10 to 3,000 like we had in the first case, but there's still some really productive estimation that you could do, right? The top three are all about 20% and the bottom two are about 10%. So if you can get to a quick estimate of whether the answer is about 20% or about 10%, you don't have an exact answer yet, but in probably a few seconds, you've already knocked out half the answer choices. That's a really good payoff for the amount of time you invested. So even cases like this, where the answers aren't, you know, the stereotypical problem where you want to estimate, where the answers go from 10 to 3,000, this is still a great opportunity to estimate. Even though it doesn't get you all the way to the answer, it at least gets you partway, halfway there. You've knocked out half the answer choices one way or the other. And that can be a really, really worthwhile thing if it's only 5 or 10 seconds of your time. Similarly, these fractions, well, they don't look all that different, right? Most of them are, you know, they're all fractions. They're not, none of them are huge. None of them are teeny. So they're all kind of close together. This seems like a bad opportunity to estimate. Actually, there's some really good headway you could make because the top three are less than 1 and the bottom two are more than 1. So if you can figure out, like, well, if the ratio of these two things is that should the numerator be bigger than the denominator? As soon as I can figure that question out, I can knock out either 2 or 3 of the answers. And so again, in a process that shouldn't take very long, a few seconds, I can knock out half the answer choices. It's a really good payoff. All of these are examples of estimation, even if you're not getting all the way to the final right answer, right? You're boosting your probability of getting it right, and you're doing that very quickly. Similarly, something like this, these are all relatively small fractions, but the top two are negative. The middle two are positive, but less than 1, they're small. And the final one is greater than 1. These are all things you can figure out pretty quickly. Should the answer be positive or negative? Usually that's a pretty quick thing to figure out, especially if you're not doing the full math, if you're just thinking about it conceptually. And then again, should the final answer be bigger than 1? Should the numerator be bigger than the denominator or not? And if you're lucky, if the answer is it should be positive and more than 1, you do have the final answer. And if you don't, you've whittled it down to 2 possible choices. So all of these are the kinds of cases where estimating can be a really positive, productive strategy, even though in the last 3 examples, you might not feel like it's a great opportunity to estimate because the answers are kind of close together and you wouldn't get all the way to an answer just by estimating. That's okay. All right, we have one question. Sagar, could you post a little more detail about what you mean? So someone's asking, can you please enlighten us how to revise chapters of Quant, like how to make a timetable for that? I assume you're asking, like, how long should you plan to study the Quant chapters? The answer is very dependent on the individual. Some people will only need, a month or 2 to knock off all the rust if you did a lot of math, especially in high school and college, and you were very comfortable with that. Other people will need many months to patch up holes. They might not have ever learned certain things on the GMAT. A lot of people have never learned, like, probability Tons of people have never learned combinatorics, which are subjects on the GMAT. Now, if you're not shooting for a very high score, those don't particularly matter. But if you're shooting for, like a 750 or something like that, then you would need to know those. So unfortunately, Sagar, I can't give you a great answer because it's a very individualized question, unfortunately. All right, moving back to the topic at hand. So let's look at another problem. So it only has 3 answer choices, but other than that, it's a realistic GMAT problem. This was one that we wrote, Manhattan Prep. So if there are 24 white marbles and 36 blue marbles in a bag, which of the following is the ratio of blue to white marbles? 3 to 5, 2 to 3, 3 to 2. I'll give you a few seconds to think about it. And now I'm going to hide the answer choices. And the reason I'm doing that is I want you to think about what should that number look like? I'll give you another 5 seconds to read the problem now that you know sort of the game I'm playing, which is that I'm not going to give you much time to think about it. So take a quick look at the problem, and I'm going to give you like 10 seconds to read it and think about it. And then in the chat, I want people to say some things. What kind of number should the answer look like? Should it be bigger than 1, smaller than 1, etc.? If you're fast enough to do the entire math in your head, great. But all right, take like 5 or 10 seconds. Yeah, so a lot of people in here are doing the full math in their head. The key point that I want to make here is blue to white. Well, there are more blues than white. There's 36 blue marbles and 24 white marbles, which means if we're doing the ratio of blue to white, you have to have a bigger number on the left. Well, the only one that's bigger to smaller is C, right? 3 to 2. That's the kind of thing where even if you're not doing the full math and realizing, okay, these are both divisible by 12, I can divide them by 12 and get 3 to 2, you know that the answer has to be greater than 1, and only one of these options does that. Right? Now, multiple people are putting that in the chat, so great job to everybody who spotted that. That's exactly the kind of thing you want to be looking for on the GMAT, right? This math was pretty easy. If you divide 36 and 24 by 12, you get 3 to 2. So for some people, that's going to be very straightforward. But for a lot of people, it wouldn't. And even more importantly, even if this was very easy for you, I guarantee you there are problems on the GMAT where the same idea applies, but where the math is a lot harder. So getting used to looking for opportunities like this to find the simple way to get to the solution is crucial, because it's going to save you a ton of time on the GMAT. And as soon as you start studying for the GMAT, you will realize time is your most important resource on the GMAT. So strategies like this are incredibly valuable. Okay, let's take a look at another problem. If X is reduced by 30%, the resulting number is 63. Now, don't do the math. If you're capable of doing the math, hold back for a second and don't do it. I want you to stop and just think about something. Are there any answers here that jump out that we could really quickly eliminate? And tell me why. Somebody put some ideas in the chat. Without doing the full math, can you knock out any answer choices here and tell me why? Give people a few seconds to have some thoughts and put them in the YouTube chat or the Facebook chat. Okay, so someone suggested that we can knock out 33 and 60. That was the first answer somebody put in the chat, and that's a great idea. Think about it. If X is being reduced by 30%, if X is being reduced by 30% to get to 63, well, X has to be bigger than 63, right? So X can't possibly be 60 or 33, because if it's larger than 63, those two answers don't work. So immediately you can knock those two out without doing any math, right? The next thing you could do is you could look at 100. 100 is bigger than 63, so it passes that initial test. But luckily, 100 is something where it's really easy to figure out what 30% of 100 would be. 30% of 100 would be 30. And if you take that out of 100, you get 70. So that one, you're not estimating, but you're purposefully seeking out the one where the math is really, really easy. So you do the math on 100, you realize, well, that would be 70. So that's a little too big. So at this point, you've already knocked out A and B because you realize the number has to be bigger than 63. You did the math on 100 because it was quick. You realize, well, that would be 70. So that can't be the right answer. So we need something that's a little bit smaller than 100. You could make an educated guess that 90 is probably about right, because when you used 100, you got down to 70, which is a little bit bigger than 63, but not too much. So 90 is probably your best bet, right? And you could do that whole process in about 10 seconds, maybe 15, once you're used to thinking about problems in this way. So that's a great example of using the understand, plan, solve framework in addition to estimating. So let's talk about what we mean by that. This is something that if you get into Manhattan Prep materials, you're going to see a lot of. So understand, plan, solve. The core takeaway here is on GMAT problems, you don't want to jump directly blindly into doing a bunch of algebra. Algebra is incredibly powerful. It will solve virtually every problem on the GMAT. But it is not always the smartest move, even for problems where it will get you to a correct answer, because algebra is time consuming. It involves lots and lots of steps, and it's abstract. So time consuming is just fundamentally bad on the GMAT. You want to get things done as quickly as possible because you're under a very intense time limit. Lots of steps is bad because that means there's more opportunity to make silly, careless mistakes. You write the wrong number down, you make a silly subtraction mistake, whatever. And finally, it's abstract. So no matter how good you are at math, your brain is better at dealing with real numbers and concrete arithmetic, meaning addition, subtraction, multiplication, division, with actual numbers rather than abstract variables. So for all of those reasons, algebra is often not the optimal solution. And the key idea behind understand, plan, solve is that you don't want to just blindly jump into doing the obvious math. You want to stop and think and make sure you're doing the smartest, easiest version of the problem. So the understand step basically means take a break, look at the problem, and before you just jump blindly into doing work, think about what a smart approach would be. And thinking about that smart approach, that's the plan phase. So look at the problem, see what the moving parts are, see if there might be any easy way to approach it. And if there is, start thinking about how would I approach that? How would I use estimation, which is what we're talking about here, or there's a bunch of other strategies working backwards, smart numbers, etc., in order to get to an answer in a way that's smarter than just using algebra. And now sometimes the result is I should just do algebra. It's really powerful, it's obvious, it works here, and it's probably the best way to do it. Fine. Algebra is not always the wrong answer. We just want you to stop and think before you jump directly in there. So the last step is whatever way you decide to approach the problem, do it. But the key takeaway here is that solve the problem, jump in and do a bunch of work. That is not the first step. It's the last step after you've come up with a cohesive, intelligent plan about how to do it efficiently. So the way that would apply here in the understand step, I want to just think about what's going on in the problem. Okay, X is going down in order to get to 63. Right? That means X has to be larger than 63. That's the understand step. Now I want to stop and think about that for a second and say, given that, is there any efficient way that I can approach the problem? Take a glance at the answers, and hey, 2 of these clearly don't work because they're not bigger than 63, which is what I need. Now I've used up that sort of one quick realization I have. Now I want to look at the answers again and see, okay, are any of these easy to deal with in a way that doesn't involve, writing a formula for this problem and solving for X using algebra? Well, sure, 100, right? Easy to take 30% of. I can deduct the 30%. 30% of 100 is 30. I take 30 out of 100. I'm left with 70. Well, that's too big. So already I've knocked out E, and D is the only answer that's really close. Very quick way to get to D is the correct answer. Let's take a look at another one. But first of all, are there any questions here? I don't want to move on. If anybody has questions, I'll give people a few seconds to put any questions in the chat, just in case there are any. There's also a bit of a lag, which means I might not see them for a minute. So, all right, we'll move on. But if anybody does have questions, I'll come back and answer them. All right, let's take a look at this problem. Arnaldo earns $11 for each ticket that he sells, and a bonus of $2 per ticket for every ticket he sells over 100. Okay, well, this is getting a little hard because now we have 2 different parts of the formula, and the formula changes as we move to higher ticket numbers. If Arnaldo was paid $2,400, how many tickets did he sell? Now, you can do the math. Some people on this call will be able to do all the math in their head. I want to ask you to pause and not do that, right? Let's think about how you could do it in a more time-efficient way, right? Because even if you're the kind of person who can blaze through this math really quickly, if I give you a more efficient process, you will just blaze through that process more quickly, and it's a fundamentally quicker process. So even for people who can do this math quickly, this is a benefit. Okay, so what are some hooks that this problem gives us when we stop and try to understand it? What are some hooks that the problem gives us that will let us tackle it in a more efficient, easier way? Well, the answers are pretty spread out. That's a pretty good hint that I can estimate here, right? I don't need to get super, super precise to spot the difference between 1 and 200 or 50 and 100. It's doubling every time, right? Roughly 200 to 500 is a little bit more than doubling, but every other step from A to B, B to C, etc., You're doubling the answer. So I don't need to be super, super close. Also, let's think about this. I made $2,400. Okay. But if I get $11 for the first 100, that means I would definitely get $1,100, right? So 100 tickets would net me $1,100. That's very quick, easy math to do. Does that knock out any answers? Well, yeah, let's start estimating. So I definitely sold more than 100 if I sold $2,400 worth of tickets, right? Because 100 would be $1,100. So I sold definitely more than that. That immediately knocks out 2 of the answer choices, right? And the way I got there was I chose the answer 100 that was easiest to do the simple math on, right? 100 is the point where the payoff starts changing, right? It goes from $11. Now you start getting a bonus of $2 extra over 100, but it's very quick to figure out 11 times 100. And that immediately knocks out 2 of the answer choices. The next answer choice that I would probably start thinking about is 1,000, right? I don't want to bother even to think about the $2 bonus. I could, but that would require some complicated math. I'd have to figure out how much money I made on the first 100, then how much on the next 900, add it together. I don't even have to do that to knock out 1,000 as a possible answer, right? Because 1,000 just times the $100, the $11. Ignore the $2 bonus. If I sell 1,000 tickets for $11, that's $11,000 worth of tickets. Now I'm going to get a bonus of $2 on some of the tickets above that, so I'll make more than $11,000. But if I only made $2,400, I could not possibly have sold 1,000 tickets. Right? 1,000 tickets would be at least $11,000, way more than $2,400. So that's another answer choice that we can knock out pretty quickly. And then you can do similar math for 500. Now, I wouldn't recommend multiplying by 5. You can, but it's much quicker to just say, hey, I already figured it out for 1,000. 1,000 was $11,000. More than $11,000, at least $11,000. 500 would be half of that. So that would be at least $5,000. It would actually be more, at least 5,500, but definitely more than 5,000. Well, that's a lot more than 2,400. Right? So I've never bothered to write a formula out for this. I haven't turned this into algebra. I haven't calculated exactly what the number of tickets is and solved that formula for 100 tickets or for $2,400. You could do that. But you can also get to the right answer of 200 by very quickly noticing a couple things. It had to be over 100 because that would be $1,100 exactly. So you knock out A and B. 1,000 is way too big. That's at least $11,000. And D is also way too big because that's at least half of $11,000, 5,500. That's way too big, much bigger than 2,400. So that gets me to the right answer without doing any algebra. And now I was talking through that, which obviously made me much slower. But if I was just doing that in my head with a couple little notes on my paper, that's, 30 seconds of thinking, 45 maybe. You probably have to read the problem. That's another 15. You definitely have to read the problem. It's probably another 15 or 20 seconds. But so you can definitely get this in under a minute if you're approaching it that way. If I bother to write out the algebra and solve it, most likely it's going to take me more than a minute. And it's going to run the risk of I make a silly math error, right? I when I'm dividing by 11, I mess up the math and I get the wrong answer. Probably wouldn't kill you here because the answers are so far apart. But my point is there's an alternative way to approach it that's just easier. No matter how good you are at math, it's easier. Okay. Again, if you have any questions, feel free to jump in the chat. Otherwise, let's move on to the next one. Okay. Key takeaway from Understand, Plan, Solve. Never do more than you have to do, right? Some people, when they take the GMAT, their attitude is like, I'm really good at math. I'm going to show off how amazing I am at math by doing this really hard math. And I'm going to do all the algebra and all the precise math every time. Okay. That's terrible strategy. No one ever sees how you solve these problems. Right? No one sees how quickly you solve them. If you're trying to blaze through all the problems and crush them all really fast and finish early on the quant section, guess what? Nobody sees that. No school is ever going to see that you finished 7 minutes early or that you used the hardest, most technical way to solve every single problem. Nobody cares. All they will ever see is whether you got right answers or not on hard problems, right? That's what translates into your score. So it is utterly not worthwhile to do more than you have to do. And that's true for the whole GMAT, right? That's not just a quant thing. Do things in the easiest way possible. Time really matters on the GMAT. It is a mentally stressful exam. Don't stress yourself out any more than you have to. And there's no reward for doing things in a harder way. So always seek out the easiest possible way to do the problem. All right, so that was a quick overview of estimation and understand, plan, solve as it applies to estimation. Let's jump to talking about benchmarking. So benchmarking it's closely related to estimation, but it's basically a way to get to a precise answer using a bunch of easier steps. And you lump all the easy steps together and it turns into a precise answer for something. So typical real life example, at least if you live in the US, of where this might happen is you get a bill and you have to come up with a tip, right? What's 18%, which is a pretty typical amount to tip in the US right now. What is it? An 18%? What is 18% of whatever your bill is? Right? So let's talk about some ways that you could get there more easily than directly calculating 18%. Right? So the idea of benchmarking is that there are certain percentages of things that are very easy to calculate, right? 10%, 1%, 1,000%. Those are all easy because all you're doing is moving the decimal around, right? So you just take the number and move the decimal over 1 or 2 slots, or to the right 1 or 2 slots, depending on exactly which percentage you're dealing with. Also, anything with a 5, 50%, 5%, those may not appear so obviously simple, but 50% is just half, right? And that's obviously not quite as easy as moving the decimal around. That's almost trivial. But cutting something in half is something that your brain is, for some reason, pretty decent at. It's the sort of real division that our brain is best at. We're much better at cutting things in half than dividing by 5 or dividing by 3 or dividing by 12 or anything like that. Most of those other numbers other than half, people will have to actually put down a pen on paper and do the math correctly. With a half, most people can at least roughly estimate it in their head pretty accurately. So half and 5%. 5% would just be take half and then take 10% of that, move the decimal over 1. The idea of benchmarking is you look for chunks like this that are relatively easy to calculate that you can then clump together to get to what you want. So 60%, well, it's just 50% plus 10%. 50 and 10 are both pretty easy to take. You add them up. That's usually easier than multiplying 0.6 times whatever number you're looking at. 9%, you could take 10% and then subtract 1%. For most people, that's going to be a lot easier than actually multiplying out 9% times something. 15 is just 10 plus 5. 65, 5 plus 10 plus 5. A bunch of examples here, right? You can just come up with pretty much any percentage you need using these easy building blocks, adding or subtracting 1 or 5% to 50 and 10, etc. The other thing you can do, so one option is this top bullet point here, which is get the precise answer by using precise building blocks that add up to exactly what you want, and you get each of the easy, precise building blocks and add them all up together or subtract them all out to get exactly what you want. The other option when estimation is a possibility is if you're looking for something that looks a lot like a fraction, use the fraction. So 65%, you could get there with 50 plus 10 plus 5, or you can notice that 65% is almost exactly the same as 2/3, right? 2/3 is 66.66666%, pretty close to 65. And very often 2/3 is going to be a relatively easy set of math for you to do as well. Definitely easier than multiplying by 0.65. Now, in some cases, it might be easier to do 50 plus 10 plus 5, but in a lot of cases, the fraction is going to be easier, especially if the answers are a little bit far apart and you can afford to estimate. So key idea with benchmarking is look for numbers that are either exactly the same as what you're looking for, or at least very, very close, but that are just easier for your brain to deal with, even if you have to break it up into pieces. A lot of people are afraid to break math into pieces because they think like, oh, that's more work and I'm under time pressure. I don't want to do more. Okay. But doing more number of things, a higher number of things that are each very, very easy and very, very likely to result in a correct answer. You're not going to mess up the math. That's often a lot better than doing one big, ugly, harder step that A, is going to be pretty time consuming, even though it's only one step. And B, you're much more likely to mess up the math. Okay. So let's talk about some common benchmarks. We already talked about 50, 10, 5, 1. Those are all really good ones to use. How would we use this to take 50% of 5860? Right? That's kind of an ugly number. If you try to actually multiply it by 0.5, that multiplication is going to get really ugly. Well, 50% is just half, right? That's relatively easy to figure out. Now, how would we figure that out? You could do it bit by bit. Half of 5,000 is 2,500. Half of 800 is 400. So you add 400 to the 2,500 you already had. That's 2,900. Then half of 60 is 30. So 2,930 gets you right to the answer. And it's just about changing the framework that you're thinking about the problem in so that the math becomes a lot easier and a lot more confident that you can do it correctly in your head, right? Because you don't have a calculator on the GMAT. That's a crucial point. What about 10%? Well, that's almost trivial. You just pop the decimal over one, boop, and it becomes 586. Right? 5% and 1% aren't really any different. You do the same math, and then you move the decimal over more. So 5%, just find 50% first, and then move the decimal over. 5% is 10% of 50%. So you just do the 50% step, cut it in half, and then do the 10% step, move the decimal over one. That'd be 293. Now, most people, if they thought about 5% of 5,860, they would think of that as very hard math, right? That is not a set of numbers that lends itself to being easily multiplied together in your head. But if you take these shortcuts, it's actually quite easy. 1%, also very easy for more obvious reasons. You just move the decimal over twice, right, and you end up with 58.6. Okay, so let's get back to the original problem. 18% of a $58.60 restaurant bill. How would you do that? Like that's kind of ugly. Well, there's a couple different ways you could do it. You could do it as 20% minus 2%. 20% is 10% doubled. So 10% is really easy. Just move the decimal over, 586. You double that. Now here, we're assuming that the answer choices give you some leeway for estimation. And in real life, this would be the case. Like you don't need to tip the guy exactly, 38 cents. You can tip, roughly. So 20% would be double 586. That's about $12, a little under $12, right? Because 586 is almost $6. 2% would just be the 12% with the decimal moved over. So all you're really doing is take about $12 and subtract about $1, and you'll get about $11. And very often on the GMAT, that's going to be close enough to identify the right answer. Even if it's not close enough to identify the exact right answer, it'll definitely be good enough to whittle it down to 2, maybe 3 in the absolute worst case. And then if you decide that that's the amount of time you have for the problem, you're in a rush, you're a little behind on time, or you don't know how to do the problem otherwise, great. You can guess between 2 or 3 answers, and that's a much higher probability of being right than guessing between 5. Okay. Sometimes, however, more precision is important. So let's say the problem asks you an item is $120 normally, but it's on sale for 40% off. Again, if you can do the math quickly in your head, hold off. Don't do that right now because I want to really emphasize the techniques we're trying to teach. I guarantee you if we used harder problems, even if you're capable of doing this really easily, you would want to use these other techniques. So, all right, so you have $100 and you're trying to figure out, can you afford an item that normally costs $120 but is 40% off? A couple different ways that we could do this. So first of all, with $100, the answer is pretty obvious because 40% off of 120, well, 40% of 100 would be $60. Or sorry, $60, $40. So if I took $40 out of 120, that would leave $80. Now we're taking 40 out of a bigger number, so we would actually be subtracting more than 40. But even if I just took 40 out, it's clear that 100 is above that. So that's an easy way to estimate that, yeah, I would definitely have enough money if I had $100. But if you change the problem a little and say $75, now it's harder. Because if you took 40 out of 120, that would get you down to 80. But you're not actually taking 40 out. You're taking a little more than 40 because it's 40% of 120, not 40% of 100. So would that be 75 or not? Now you actually have to think a little bit more precisely. Right? The first version you could do with a really rough, quick bit of math. The second version, you need to be a little more careful. So how can we do that efficiently? Let's talk about some ways to do it. Well, 10% of 120 is 12. So one option is you take 10% of 120 and you multiply that by 4 to get 40%, and then you subtract it. So that would be benchmarking, right? Benchmarking means breaking up the math you have to do into these sort of benchmarks, these very easy chunks that you can do quickly and then combine them to get what you need. So one option is 40% would be 48, 4 times 12. Right? And then you'd have to subtract 48 from 120. Now that's a little bit of math, but it's not the end of the world. Couple ways you could subtract 48. You could do it directly, or you could recognize, hey, 48, just take away 50, right? If I take 50 out of 120, that's really easy. That's 70. But I took $2 too much away. I shouldn't have taken away 50. I should have taken away 48. If I take away 50, I get down to 70. But then if I add back in those $2 extra that I took out that I shouldn't have, that would be 72. So that's a relatively easy way to do it as well, which is another form of benchmarking. Instead of trying to directly subtract 48, which is kind of ugly, take out 50. That's quick. That gets me to 70. And then the difference between 50 and 48 was $2. I took $2 too much out of it. So I want to add $2 back. That gets you to 72. So that's one way that you could use benchmarking. Let's talk about a slightly different way you could use benchmarking. So same problem. Sorry, that part of the slide repeats. Well, one way to think about 40% off is that it's 60% of the thing you're starting with, right? 40% off is the same as 60% of whatever you originally had. So one way we could do this is, what's 60% of 120? 60% is just 50% plus 10. And those are both very easy chunks of math to do. 50% of 120 is half of 120. That's just 60. 10% is even easier. You just move the decimal. That's 12. And now you're just adding two very easy numbers together. 60 and 12 makes 72. Right? So that is sort of like benchmarking, except the key is benchmarking you're definitely using in this step where you say 60% is 50% plus 10%. But you also have to have this other realization that there's two different ways to look at the problem. You could figure out what the 40% is and take it out. Or you could say, hey, if I'm taking 40% out, I have 60% left. Let me just directly figure out what that 60% is. That might be easier. So the key lessons here are this: no matter how you do the math, the first way I showed or the second way you showed, it's definitely easier than multiplying and subtracting the 48 directly, right? Even if you're the kind of person who that would be very easy for, right? A2D2 Charlie, I'll get to your comment in 1 second. So benchmarking provides an easier way to do the math, no matter how good you are at the math, just by identifying some easier ways to think about it, reframing how you're thinking about this problem. Don't think about it as 0.4 multiplied by 120, 120 minus whatever that result is. That's one way to do it, but there are easier ways to break up the math. Okay, there's a comment that 50% of 120 is 60. That's correct, but minus 10% would be 60 minus 6, which would be 54. That would be wrong. And the mistake is, so you took 60%, or sorry, you took 50%, and then you subtracted 10%. We don't want to subtract the 10%. We want to add it. And it's also, the 10% is 10% of 120, right? Because we're trying to get 60% of 120. Well, 60% of 120 is 50% of 120 plus 10% of 120. So the reason you got the wrong answer there was you subtracted the 10% instead of adding it. And also you took 10% of 60. We don't really care about 10% of 60. The reason we have a 10% here is because we want 60% of 120, and we break that into two pieces, 50% of 120 and 10% of 120. And then we add those together, and that gives us 60%. Okay. Again, if you have any questions, feel free to pop them in the chat. Charlie, thanks for that question. That was helpful. All right. So you could also do 10% times 6, right? 10% is 12. That's pretty easy to calculate. Now multiplying that by 6, some people may actually have that memorized. That's not a bad number to memorize, the multiplication tables all the way up to 12. Those are pretty helpful in the GMAT. So if you have that memorized, great. 6 times 12 is 72, and you're done, right? Even that is slightly easier than just multiplying 0.6 directly, right? The key is you're breaking it up into easier chunks that you're confident you can get quickly in your head. All right. So we already talked about understand, plan, solve, right? Now let's talk about it quickly again. So what we've seen here is the first thing that we want to do when we see a problem is we want to understand what the moving pieces are, right? Now, to some extent, you have to do this no matter how you're going to approach the problem, right? You need to read the problem. And even if you're going to turn it into a formula, an equation, and do algebra on it, you still need to understand the moving parts of the problem enough to translate it into an equation, right? So obviously, everyone's going to understand the problem to some extent. The key difference here is that you're not just looking at it from a perspective of like, what math is involved? How do I turn these words into a formula? And then let me go do the grunt work. You're looking at it more from the perspective of, do I see any non-obvious, easier ways to approach this problem, right? So not the straightforward, turn it into a formula and do a bunch of algebra, but is there a quicker, lighter, easier touch that I could take that would get me to the same place? Remember, all I need to do is pick A, B, C, D, or E. I might not need an exact number. So let me think about, are there smarter ways to get that? And then once I identify a possible course of action that would be easier, plan out how I'm going to do that. Right? Okay, I think I could break this up. I think I could use benchmarking. I think I could use easier chunks of percents and add them up. Now I'm going to plan out exactly how I'm going to do that. So if I'm going to do 18%, well, maybe I take 20% and then find 2% and subtract that. Maybe I find 10% and 5% and 1, 3%, add them all together. A few different ways I might want to go about it depending on the particular problem. And then I actually want to go ahead and do that work. But the goal is when I'm getting to the solve step and I'm actually doing work, I am doing the easiest possible version of the work, not the straightforward, obvious version that the GMAT is trying to suck me into. Okay. There's a very broad question in the chat. According to you, what are the best test-taking strategies which will result in the best possible score? I'll talk about that a little bit at the end of the session. I'm going to put that question off only because it's so open-ended. I want to make sure we cover all of the material here. And then once we've gotten through the material, I will address that question as best I can. Although I will say that that is a very general question that has a long answer. So I'll give some thoughts on it toward the end of class. Okay, so we're going to close with a bunch of different ways to look at this one problem. Again, some of you will be able to do this math out exactly, although I think pretty much everybody here would have to use some pen and paper. Maybe you can store it in your head, but don't do that. Hold off on doing the actual grunt math here. I want to talk about different ways we could do this that are more efficient and that will be helpful to see. So first, let's read the problem. A certain bakery has 6 employees. It pays annual salaries of $14,000 to each of 2 employees. So 2 people are making $14,000. $16,000 to 1 employee, and $17,000 to each of the remaining 3 employees. So you have 2 people making $14,000, 1 making 16, and 3 making 17. The average arithmetic mean annual salary of these employees is closest to which of the following? Okay, so let's stop and understand this problem for a second, right? Let's go through the understand, plan, solve framework as it applies to this problem. Okay, understand. Well, they're asking us about a weighted average, right? Now, the standard straightforward way to do a weighted average is you add up all the numbers and you divide. We could do that, but it's a lot of addition. Dividing by 6, this is unlikely to be a number that cleanly divides by 6, at least at the rounded to 1,000 level. So that's probably not going to be super fun math. Long division is something that whenever possible, you definitely want to avoid long division. Right? Okay, the problem says closest to. That is crucial language. That means that these answer choices are not the exact answer. They're just close to the exact answer. So we just need to figure out which one is closest to the exact answer. That means we can afford to estimate. Someone posted 3 get paid $17,000, so the average will hinge towards $17,000. Good. That's exactly the right kind of instinct. So we're going to talk about different ways where you can get to that more precisely, right? Because the problem here is 15,200, 15,500, 15,800, 16,000, 16,400. Kind of hard to tell which one of those skews enough towards 17,000 without a little bit more thought about it, right? So one option here would be we do the straightforward math. We add them all up and we divide. But again, not the best idea. Long division is probably not something you want to be doing very often. So here's one other option. I'll give you a few different ways to approach this, but one is pair off extreme values and basically average those two together to push everything closer to the middle and see where everything's coming out. Part of what is hard about this problem is you have some things over at 14, some things over at 17, one thing in the middle at 16, and you're trying to figure out like exactly where does this balance. Well, one way to resolve that is take the stuff on the ends, average it together, and then see where that sits. And now we're just sort of squishing everything closer and closer to the middle, which gives us a better idea of where that perfect, exact, true middle, that average, is. So let me show you how to do that. So if we match up, oh, sorry, I forgot that we go through this first. So this is the option of adding everything up. 14 and 16 is 30, plus another 14 is 44, 17 times 3 is 51. You add all that up, you get 95. 95 over 6, not the cleanest number, but you can break it up. 60 over 6 and 35 over 6. So 60 over 6 is easy, that's 10. 35 over 6, now here we're going to use a little estimation. 35 over 6 is just under 6, right? Because 36 over 6 would be exactly 6. So we know that we're just under 16,000. Now that might be enough to get to the answer. It points us towards C. We definitely know D and E are wrong because we have to be under 16,000. Maybe there's a little doubt about whether it's B or C, but the most comfortable guess here, because 35 over 6 is so close to 36 over 6, we're only a little bit under 16,000. That points at C being the right answer. Right? So that's just walking through what I was saying. So let's talk about pairing the high values, right? If we pair the high values and the low values, 14 and 17, there's two exact matching pairs. Those average out to $15,500. Now, how can you do that? You could add those up. 14 plus 17 is 31, divided by 2 is 15.5. That's one way to do it. Another way to do it is just think about it mentally. So 14 is over here and 17 is over here. If I move them each one unit closer to each other, the 14 turns into a 15, 17 turns into a 16. Now I have 15 and 16. How do I average those? Well, that's easy. The average of 15 and 16 is 15.5. It's right in between 15 and 16. So even this step, there's two ways to do it. You could do the straight up arithmetic where you actually do out all the math, or you could look for an easier way to figure it out quicker with steps that are easier for your brain to grasp. So if the 17 and the 14 all get replaced by 15.5, because we figure out that that's what happens when you average them, the new set that we have is 15.5, 15.5, 15.5, 15.5, 16, 17. And now what you notice is every single number is 15.5 or bigger, and a couple of them are bigger. So that means the average can't possibly be 15.5 exactly, because the 16 and 17 are pulling it a little up, and it also can't be 15.2 because that's less than any number on here. So that quickly knocks out two of the answers. And then we could say, okay, well, the only spread that's left is this 17 and the 16. So let me take the 17 and see if I can move the 15.5 up and the 17 down. Well, if I take a half out of 17, one of these 15.5s will become a 16. So now the 17 is down to 16.5, and I have two 16s. If I take another half out of the 17, what was originally the 17, now that's down to 16, and two of the 15.5s have turned into 16. So now the new list that I have, I'm sorry I can't type this on the screen. Due to a technical issue, I can't type on the screen right now, unfortunately, but the first two 15.5s stay 15.5. But the next two have turned into 16s because I took little chunks out of the 17. And the 17, because I took two 1/2 chunks out of it, that's also turned into a 16. So I have two 15.5s up at the top and then four 16s down at the bottom. That gets you to somewhere between 15.5 and 16, leaning a little more towards 16, which tells us the answer has to be C. It's less than 16,000, but close to 16,000, which gets us to C. So again, I apologize that I can't type. That would be a lot more clear if I could have scratched out stuff, but hopefully you followed that. The idea there is, instead of doing the math and adding everything up and dividing it by 6, I'm just sort of piece by piece pushing things towards the middle in a way that maintains the average, right? I'm not just randomly changing the number. I'm taking 14 and 17, pushing them both towards each other and saying, well, if I make the 14 a little bigger and the 17 a little smaller, the average won't change. And I'm just continuing that process bit by bit until I get to a set of numbers that helps me figure out exactly what the answer is. And that's going to be a lot quicker for a lot of people. And actually, even more importantly, it's going to be more accurate than trying to divide an ugly number by 6 in a lot of cases. Okay. So Another way you could approach this is you say, hey, there's a nice clean number in the middle. There's a 16,000. 15,800, 15,500, 16,400. Those are a little hard to think about, but 16,000 is a nice clean number. Can I figure out whether the average should be above or below 16,000? Right. Okay. Well, let's take some quick examples and talk about how we would think about them. 10,000, 16,000, and 17,000. If I look at those, the 17,000 is pulling the average up by 1,000 more than the 16. Right? If we think about 16 and we're asking, does this set of numbers perfectly balance at 16? Is 16 the average, the balance point between them all? Well, 17 is 1,000 above that. But 10,000 is 6,000 below that. That 6,000 gap is going to pull harder than the 1,000 gap going up to 17. So that's going to pull the average below 16. We have this way of explaining weighted averages called the teeter-totter method. This is getting a little bit in the weeds on weighted average technique specifically, but basically the idea is when you have a weighted average, think about it like a physical teeter-totter, a balance beam, a seesaw, whatever you call that piece of playground equipment where two kids sit on a metal bar and bounce each other up and down. And the question you're asking yourself is, where is the average, the balancing point between all the numbers in my set? Well, 17 is only pulling its side a little bit by a 1,000 difference. Whereas 10,000 is pulling its side a lot. There's a 6,000 difference between that and 6,000. That would pull the average down. So this set would not average out to 16,000. It would be less. But what about 15, 16, 17? Now that does average to 16 because 15 is one below and 17 is one above. So that averages perfectly out to $16,000. And you can do the same thing with larger sets of numbers. 15 and a half, 15 and a half, 17. That does average out to 16 because the 17 is 1,000 above. It's pulling it a little bit up. The 15 and a half, those are each half 1,000, so 500, below 16. So total, the two of them are pulling it down by 1,000, and the 17 is pulling it up by 1,000. That balances out. So that means 16 would be the average here. Now, if we look at the set we actually had, right, this is the set we got when we realized 14 and 17. If you take those extreme values and average them, they turn into 15 and a half. So instead of 2 14s and 2 17s, we're going to have 4 15 and a halves. Now we can ask ourselves, does this average out to 16? Because 16 is the middle number of the answer choices that we have left. Well, 17 is pulling that average up by 1,000. 15 and a half is pulling it down by a half, but there are 4 of them. So the total of all of them together, you're pulling it down by 2. That means the average is going to be somewhere below 16 because the stuff below 16 is pulling harder than the stuff above 16. So that means the average has to be less than 16, and the only answer choice left that does that is 15,800. So that's basically what I just walked through there. So the point is that I didn't ever do the math of adding everything up and dividing by 6 exactly. And I showed a few different ways to do this. Some I just sort of thought about conceptually. What does this look like as a teeter-totter? How does the balance come out? I took some of my more extreme values and squished them more towards the middle so that things were closer together and easier to think about. There was one version that I showed where I did do some math, but I simplified the math. I didn't exactly divide by 6. I said, well, instead of taking 35 over 6 and doing that precisely, I'm going to say, hey, it's the same as, it's just under 36 over 6. Sorry, 95 over 6. Anyway, the point is I didn't do the exact math ever in any of the ways that I showed you how to solve this problem. I did easier approaches, and there were a variety of them. There's no one right answer about how to approach a particular problem, but all of the approaches I took were easier and more likely to be accurate than doing long division. Okay. Yeah, so some people are posting the estimation method is going to take some time to get familiar with. That's totally true. And that's true of pretty much every good strategy on the GMAT. So if you watch other Manhattan Prep materials, you might see us talk about things like working backwards, smart numbers, estimation, and benchmarking are the two that I talked about today. All of those strategies are incredibly powerful. And if you talk to people who are really, really good at the GMAT, even if they don't realize they're using them, if you watch how they solve problems, they're doing all these things sort of intuitively. It's often the gap between someone who's okay at the GMAT and someone who's great is this intuitive instinct to use these strategies. But if they don't come intuitively to you, they all take practice. So that's an important point to realize. None of this stuff is just like, hey, I saw someone talk about it for 5 minutes and boom, it worked, right? Think about how many years you've spent getting good at algebra. You've been doing that since maybe middle school, maybe high school, but a long time, many years. Well, you're not going to get good at these new approaches in a day, right? It's going to take you weeks of working on them, practicing them. First of all, just practicing that you spot the opportunity to use them, and then identifying what is the best way for me personally to actually use this, right? If I want to calculate 18%, for example, a bunch of different ways I do that. I could take 20 and subtract 2 out of it. I could take 10 and 5 and 3, which would be 1, 1, 1. I could add all that up. So there's a bunch of different approaches, and you need to get used to these strategies in the sense of figuring out for you individually, in the detail, the level of detail, what is the best way for you to apply them. Okay, bunch of questions that are very general, so like GMAT exit strategies, timing strategies. Let's get into all that. So let's fly through the rest of this. This is just a visual description of what I was talking about, where you think about it like a teeter-totter. There are a lot of different steps to understand plan solve. We didn't talk about it in a ton of detail, but I think that's okay. This stuff is all very deeply woven into the Manhattan Prep textbook materials. So if you buy the textbooks, there will be tons of description about how to think about understand plan solve. The main point that I really want you to take away today, the one bullet point lesson of understand plan solve, is don't blindly jump into a problem and start doing it in the most obvious way. Sometimes that most obvious way is the best way to do the problem. But very often on the GMAT, it is not the best way to do the problem. It'll work, but it'll be slow and you'll be more likely to get a careless mistake. That's the main takeaway. Okay, so time for Q&A, and we'll wrap up in a few minutes. So I'm going to go through the questions. Okay, there was a very general question a few minutes ago about what are the best test-taking strategies which will result in the best possible score. It's an extremely open-ended question. I think the biggest lesson I have related to quant specifically is sort of the theme underpinning the discussion we had today, which is do things in the easiest way that is most likely to result in an accurate answer. There is no benefit to doing things in the brute force hard way to prove how smart you are. Nobody sees how you approach the problem. So do it in the way that is most time efficient, least stressful, and least likely to generate a careless mistake. One general principle that I think is important that applies very thoroughly on verbal and still to a large extent on quant is rather than think about your job being to hunt for the correct answer, you should think about your job as eliminate the wrong answers. And very often that'll do two things. It'll be quicker and you'll be more confident in knocking out wrong answers than you will in selecting the right answer. That's not always going to be the case. But especially on like critical reasoning problems, sometimes it's hard to justify exactly why the right answer is right, but you can spot clear flaws in a lot of the wrong answers. Sentence correction, you're not reading a sentence and telling yourself it's right. You're looking for specific flaws that you can identify that violate particular rules. So you're always trying to approach the GMAT from a perspective of knocking out answers rather than justifying a particular answer. And the big benefit of that, in addition to the fact that I think in a lot of problems it's more accurate, the big benefit of it is if you realize that you're running out of time and you have to move on from that problem, you're picking from a smaller set of remaining answers, and those are higher quality remaining answers. You've knocked out the worst answers first. So that's a general point about approach that I think is really important. Is it possible to have a timeline about this marathon? So again, that's a very individualized thing, a very individualized answer. I would say on average, people have to study for the GMAT for somewhere between 3 and 5 months. You can absolutely shorten it, but most people hit their sort of plateau in terms of their score somewhere between 3 and 5 months in. Obviously, that is affected by how many hours a day you can afford to study. So if you are full-time on the GMAT, you're in between jobs or you just finished school or something like that, amazing. You can definitely do it in a lot less time because you can spend 8 or 10 hours a day studying. So if you assume 10 to 15 hours a week, which is what we generally assume someone's going to be able to commit if they're full-time in school or working, generally 3 to 5 months is the right amount of time. Share some advice on exit strategies. I'm at a stage where I feel I can solve most P&C probability time-taking questions. When do you decide to cut your losses? Okay, so on the quant section, the timing is pretty straightforward. You have exactly 2 minutes per problem on average. Generally at Manhattan Prep, we advise that at around the 3-minute mark, you definitely want to cut your losses. At the 1-minute mark, if you are not confidently on a path to solving the problem, you've already figured out what you're going to do. So you've done the understand and the plan steps of understand, plan, solve, and you're just in the solve step where you're doing the math. By the 1-minute mark, you should be on the solve step. You should be in your process. You know what you're doing. You just have to bang it out. You've read the problem. You've understood it. You've figured out your strategy and you're doing it. If at the 1-minute mark, you are still struggling to understand the problem, or you understand it, you read it, but like you're not really sure how to approach it, what to do, you haven't written anything down on your paper yet, definitely bail. And at the 3-minute mark, the payoff for continuing to work on the problem gets really, really low. The biggest signal that you are getting if you're spending more than 3 minutes on a problem is that problem is too hard for you. And so we constantly convince ourselves like, oh, I can get it. 10 more seconds, 30 more seconds. I'll get this. I'll get this. Bail. The likelihood after the 3-minute mark, the likelihood that incremental time will drive you to the correct answer is no better than chance. There's a lot of data on that. So just cut it. All right. So we are right at the 1 hour mark. I will put this up in front of everybody because it's useful. So I will answer a couple more questions after. I'm happy to stay a few minutes over, but I want to make sure we cover this stuff. So if you're going to study for the GMAT, don't block out an 8-hour block on Saturday and say, I'm going to do every Saturday 8 hours and study the GMAT. You're not going to follow through on that. Number one. Number two, your brain is not going to absorb information very effectively for 8 straight hours, right? Much more effective, block out 1 or 2 hours a day, 3 or 4 weekdays, and maybe a 3 or 4 hour chunk over the weekend. That is much more reasonable. You're actually going to be able to follow it. You won't be depressed. Much better way to study. Second recommendation is use flashcards. You don't have to write when I see X, I will do Y, but you generally want to structure your studying in a way that is action-oriented towards particular problems you've faced. Not problem meaning a GMAT problem with a number and 5 answer choices, but like particular thorny issues you faced that confused you. Flashcards are a very powerful way to do that. So you write, some sort of prompt or rule or question on the front and the answer on the back. And the other is always be realistic when you're doing your practice. Treat it like a fake test, right? Practice your test day behavior. So if you're doing official guide problems in the GMAT official guide, do them in a time limit. 2 minutes per quant question, minute to a minute and a half for verbal questions, 2 for critical reasoning. But make a time limit on your problem set. Time yourself. Do it. Don't look at the clock because you don't want to stare at the clock the whole time during the test. Just make every little bit of practice you do as close a simulation of the real GMAT as possible. Okay. We have a free starter kit for everybody. It's available at manhattanprep.com. Strongly recommend it. A lot of useful stuff in there. Also a free practice test, which is incredibly valuable. And if you want to take any of the paid Manhattan Prep courses or tutoring or anything like that, GMAT Club 75 will get you $75 off, 75% off a complete course. That might be a typo, but I don't know. I don't know if maybe it is 75%. Anyway, that also says through December 31, 2022, which clearly, well, maybe that is true. Anyway, GMAT Club 75 for a discount. You can reach out to student services at manhattanprep.com if you have questions about exactly how it works. But just wanted to make sure I covered that. Okay, so GMAT Club 75, remember that code. Let's go back to the Q&A slide, and I will answer as many questions as I can in the next few minutes. Should we think about spending more time on one question every 7 to 8 questions? No, is my simple answer there. The best way to manage your time on the GMAT is just to target having very steady Eddie timing, just being consistent. There's not really any better timing strategy than just trying to target 2 minutes plus or minus 30 seconds for every single problem throughout the entire quant section. Verbal is a little more complicated because of the reading passages, and critical reasoning problems do take longer than a reading comp or a sentence correction problem. So it's a little bit more messy. But the core idea is the same. Maintain consistent timing through the GMAT. If you try, the real problem with all those other strategies that are out there, they're very hard to manage mentally. So are you going to remember exactly how many problems it's been since you spent extra time on a problem? Probably not. Also, spending extra time on a problem, unless you're spending less time on the ones before it, you're just taking that time away from another problem. It's a zero-sum game. So there's not really any benefit to spending extra time on certain problems and under time on others. It'll just naturally happen. Sometimes you'll get a problem right in a minute or minute and a half. Sometimes it'll take 2.5 minutes, maybe even up to 3 minutes. that's okay. Like that little bouncing around is no problem. It is never a smart idea to spend 4 or 5 minutes on a problem. There's a misperception that it's worth doing that at the beginning of the test. For some game theory reasons I can explain in more detail, we don't have time for now. That is bad strategy. Just target consistent, straightforward time. It's easy to keep in your head, and it's a relatively easy target to try and maintain. And it is optimal strategy, actually, as well. Just reading through the remaining questions to see if there's word problems take a lot of time. It gets difficult to chalk out an inference. How to tackle those? Word problems, I'm assuming, because you're mentioning inferences, I can't tell if you mean word math problems or word problems meaning like verbal problems. And how to tackle those is much more of an in-depth response than I have time to get into. So I unfortunately am just going to skip that problem because I don't think I can give you a productive and useful answer in a minute or two. If I'm behind on time, I bail on one question in each 5 questions so that my mistakes are varied across the section. That's a good strategy. If you're behind on time, bail on a question so that you catch up on time. If you've spent a lot of time studying for the GMAT, you can afford to be a little picky and select, in the next 3 or 4 questions, I know I need to skip one, so I'm going to pick one that I know I'm pretty bad at. But if you're earlier in your GMAT studies, don't think about that. Just as soon as you notice that you're more than a couple minutes behind time, skip. Just skip one. Now, when I say skip, I mean pick an answer without thinking about it and hit submit, because you can't actually skip a problem that you met. But you want to catch up on time as soon as you notice you're behind. It is never a good idea to bury your head in the sand and say it'll get better, it'll magically fix itself. It will not. So skip a problem to catch up. After a full day of work, my brain feels tired and prep feels boring. Any tips on this? Yes, study before work. Wake up an hour early. It is so much better. Because you're right, you will be tired at the end of your day work. So wake up, whatever time you wake up now, wake up 90 minutes early, spend those 90 minutes studying for the GMAT 4 times a week. And then a couple hours in one chunk over the weekend. And that'll be 10-ish hours of studying. That'll be a good amount. How do we practice reading comprehension? Again, that is a very lengthy answer, and this is a quant section. So I'm gonna skip that question just because I can't give a productive, useful answer in 30 seconds. Okay, someone has suggested this. I can give a quick answer to. It's a verbal question, but in order to balance time in the verbal section, I'm thinking of skipping one passage. Do you agree with skipping the last passage? 100% absolutely not. Do not skip an entire passage. If you skip an entire passage on reading comp, you're going to miss 3 or 4 problems, right? You'll have an 80% chance of missing each one of those. So your expected number of misses is high. It's 2 to 3, or 3 to 4 if there are 4 questions. Not worthwhile. You do not want to miss 3 or 4 questions in a row on the GMAT. That will do real damage to your score because of the way the scoring algorithm works. Every time you miss a question, you get an easier one. And basically the difficulty level of the question you end up on is where your score is. So don't do that. Do not skip an entire passage on reading comp. All right, we're well over time, about 10 minutes over, so I'm going to go ahead and wrap up. Again, remember that code if you do end up signing up for a Manhattan Prep course, GMAT Club 75, well worthwhile. Thanks everybody for joining. It's been great. I've enjoyed all your questions. Thanks for being so active on the Q&A. That's very helpful. It makes me feel more worthwhile. And yeah, I hope what we talked about was valuable. Thanks so much, everybody.